Welcome back. In this lesson, we'll resume our journey in uncovering Python data types, more specifically the none type and the numeric type. I hope you enjoy. First off, we use the none type when we want to represent an absence of a value or a null value, and is denoted by the keyword none. None is a special and highly used keyword because it provides a consistent way to represent nothingness across various contexts, especially in the context of initializing objects and even returning objects from functions, in cases where functions do not explicitly return anything. A good example would be if I want to characterize my romantic life, which is obviously none. While we are at it, let me give you a tip to quickly know the data type of a variable. You can use the type method and within parentheses write your variable. For example, we can say that my romantic life is a none type, which unfortunately makes total sense. Another function worth mentioning is the isInstance function, which evaluates your variable against a predetermined data type. For example, if I evaluate the same expression against the Boolean type, I will return false, since it's not a Boolean, but a none type. I didn't mention earlier, but when I talk about functions, these are essentially a block of code that performs a specific task. The result of that task can return anything back to the previous call or nothing at all. You will hear me saying function and method interchangeably, which in the context of this course, they are the same thing. Alright, perfect. Let's move on by introducing you to the numeric types. The last type of this lesson. I want to briefly mention two numeric types, integer and float. The integer, or shortly abbreviated as int, represents whole numbers without any decimal parts. They can be positive, such as the age of a person. They can be zero, like my bank account balance, but they can also be negative, like the current temperature outside. The float type represents decimal numbers, meaning they include a fractional part. The name float comes from the floating point representation, which is a standard way to map bits, meaning ones and zeros that your computer can process, to numbers, by splitting groups of bits into. I'll share a link in the description if you want to read more about it. To define a float, you want to separate the whole part from the decimal part with a dot. I'm putting here some of the basic operations and the signs you need to use in Python. What I want you to retain is that we use the plus sign for additions, the minus sign or hyphen, depending how you want to call it, for subtractions, the asterisk for multiplications, and the forward slash for divisions. You may see in the future cases where numbers can come in as text, but you will need to transform them into numeric type to perform operations. My recommendation is to try to use integers over floats whenever applicable, since they occupy less memory and speed up operations. For example, if you have fields in your data that represent ages, counters, and indexes, these usually can be converted to integers if they are not already in this format. In this case, I represented the text data type within double quotes and used the in function to transform to an integer. But don't worry, you'll learn more about this data type in a future lesson.